Hello, today we will talk about the non-homogeneous second order differential equations. You know that this is the general form of the second order linear differential equation. And so far we talked about constant coefficient and homogeneous case, which means that our g of t function was 0. But now today we will focus on if g of t is not 0. For the first method, we will talk about method of undetermined coefficient. For this method, if your right hand side is either polynomial or exponential or sine and cosine, if you have this kind of functions for g of t, you can use method of undetermined coefficient easily. Let's see how we are using it. I will give you this table and I want you to understand this table very well. G of t is one column and we have the trial form for the particular solution. So since I said this one particular solution, what is the other solution? Other solution is complementary solution. And you already know how to find the complementary solution. It is coming from the homogeneous part. So as a first step for the non-homogeneous case, you need to solve the homogeneous part, where the second order differential equation is equals to 0. And for that one, we are calling this one as a complementary solution. And y particular is the solution for the right hand side, which means that it's coming from the non-homogeneous case, g of t function. Okay? So here you go. If your right hand side, g of t, is a polynomial, you are going to be looking for a solution in that form. What is that form? T to the s, a power function, times nth order polynomial. So here you need to know what is n and what is s. N is coming from your g of t. Whatever you have a polynomial, let's say if it is a second degree, your n is 2. If it is a first degree, your n is 1. If it is just a constant, n is 0. So you will assume your solution in the parallel way. And for s is how many times 0 is coming as a root or in the characteristic equation. So you know, as a first step, you need to solve the homogeneous part. And when you are solving the homogeneous part, you need to write the characteristic equation first. Remember that we did it in the last class. And from the roots of this characteristic equation, you are going to be looking for 0. If it has a 0 as a root once, your s is going to be 1. If it has a 0 as twice, your s is going to be 2. If there is no 0 as a root, your s is going to be 0 at that time. Okay? And as the second row suggests, if your g of t function has also an exponential, you will be looking for a solution with an exponential like that. So in here you need to decide what is s, what is n, and what is alpha. Alpha is given directly, n is given directly, and s is this time is how many times alpha is coming as a root of characteristic equation. So I'm sure you don't understand anything right now, but on the example, it will be getting clearer. Okay? So, and the last row, if you have cosine or sine function, you will be looking for a solution with cosine and sine function. Okay? Either you have cosine or sine, it doesn't matter. The solution form that you are going to be looking for is t to the s, e to the alpha t, nth order polynomial, cosine beta t plus nth order polynomial sine beta t. So in here you need to know what is alpha, what is beta, what is n, the polynomial, and s is how many times alpha plus e beta is coming as a root of characteristic equation. So it will be either 1 or 0. Okay? So let's look at it on an example and things will be getting clearer. Look at that one. This is a second order differential equation, and for the homogeneous part, you know how to solve it, because we know that we are looking for a solution in the exponential form, and once I plugged in, I can get the characteristic equation like that, r squared minus r minus 2 equals 0. And for this characteristic equation, I can factor out easily. I can get 2 and minus 1 as a root. Since I have two distinct roots, I can put them as a power of an exponential, and this is my complementary solution. Look at that, your roots are 2 and negative 1. It is important to find them because these are gonna give us the what is S for our complementary solution, okay, for our particular solution, sorry. Look at that. Now let's go to the step 2. We need to find the non-homogeneous part. For that we need what is g of t. So there is a polynomial, 0 order because it's just a constant, and an exponential, and e to the alpha t, alpha is 3. So what I know, alpha is 3 since it is given here, n is 0 since it is just a constant, I have only 8, and s is, remember that it fits to the second row. There's an alpha and polynomial, and s is the multiplicity of alpha as a root of characteristic equation. So we will be looking how many times alpha is coming as a root. What was my alpha? 3. Is 3 is in my root in the characteristic equation in first step? One of them is 2, one of them is -1. No, there is no 3. That's why our s is 0. S is the multiplicity of 3, and since 3 is not a root of the characteristic equation, then S is 0. Now I can check, in here I just gave a note, if this characteristic equation would be r minus 3 squared, 3 is coming twice, S would be 2. If that would be r minus 3 times something, 3 would come once and S would be 1. But since there is no 3 coming as the characteristic equation's root, so S is 0, okay? Now let's turn back. I will be looking for the solution. Our P on T is just first order, that's why it's, sorry, zeroth order, so that's why we have only constant, and e to the 3t, because remember the table, t to the s, s is 0, t to the 0 is 1, I have only n is 0, that's why I have only I is 0, e to the alpha t, alpha was 3, so I'm looking for a solution in the form a0 e to the 3t, okay? And since my solution is in that form, I'm trying to find what is a0. To be able to do that, I need to take the first derivative first, then second derivative, then I need to plug in this inside my equation. What was my equation? Y second derivative minus y first derivative minus 2y equals 8e to the 3t. From the beginning, remember that. This was my equation. I will plug it inside this equation. And if I plug in and make it equal to the right hand side, here you have 9 a0 e to the 3 for yp second derivative. Here just plugged in this. Here just plugged in that. Do the calculation. You have 4 a0 e to the 3 on left. You have 8 e to the 3 on right, which means that 4 a0 is 8. a0 is 2. Just plugged in ypt. Ypt was a0 e to the 3, so you have 2 e to the 3 as a particular solution. And as a next step, you need to sum the complementary solution and particle solution for the general solution of your differential equation. Okay, and here is it. So in this one, it is important for you to understand how you are finding the right trial form of your solution. Okay, let's look at another example. Look at that, second derivative minus 3y derivative equals t squared. As a first step, I need to solve the homogeneous part once this right hand side is 0. So I'm writing the characteristic equation r squared minus 3r 0, and for that one you can factor out r. You have 0 and 3 as a root. Again, you have two distinct roots, and e to the 0t is gonna be 1, so you have only c1, and 3t is coming from the second root. Okay, and now as a next step, I need to find the trial form of my solution. Since this is just a polynomial, let's remember this table, and in this table, if we have only polynomial, I'm looking for the solution t to the s times the polynomial, and s was how many times 0 is coming as a root in the characteristic equation. Okay, so that's why let's check that. Since this is second order, my n is 2, I can directly say that, and s is how many times 0 is coming. Let's check the first step. Is 0 in the root? Yes, it is. 1, it's coming once. That's why s is 1. Now I can write my trial form t to the s nth order polynomial, but my n is 2 and my s is 1, so I plugged in 1 for s and I will get the second order polynomial here because n is 2. N is 2 because my gt is t square, right? And if I multiply with t, I will get this one as a trial. I need to take the first derivative, second derivative. I need to plug in inside my differential equation, the original one, make it equal to t square, plugged in the second derivative and the first derivative here, and check that out. There is a t square term, there is a t term, there is a constant term on left, but on right there is only a t square term. That's why I need to make this coefficient equal to 1 because t square coefficient is 1. Other coefficients, this term and that term, should be 0. And exactly this is what I'm doing. From the first equation I can find a2, plugged in here, find it a1, plugged in here, find a0, and after that plugged in all those in the particular solution form. What was that? This was that here. And as the next step, just write your general solution as particular plus complementary. This is coming from the homogeneous part plus the one that we just found from the particular solution. Okay? It is easy, just you need to understand how you can find the trial form. And another example I want to show in here to you. This is the third example. And in your Pearson, MyLab, you can find different examples. Again, this time we have two functions as a sum. It's coming as on the right hand side. And one of them is exponential, one of them is sine. So I can use method of undetermined coefficient for both. And that's why I will solve them separately, and at the end I will sum the solutions. Okay, you can do that. So firstly, let's look at the 3e to the 2t. Alpha is 2, n is 0 because there is no t term as a coefficient. And of course, as a first step, I need to solve the left hand side, the characteristic one. R square minus 3, r minus 4 is 0. Find the roots, r4, r negative 1, and this is my complementary solution. You already know that very well. And now let's start with 3e to the 2t. As I told you, alpha is 2 because here e to the alpha t, remember that alpha was coming as from the power of an exponential. N is 0 because there is no t as a coefficient, it's just a constant. And s is how many times 2 is coming as a root. Let's look at the characteristic equation. There is no 2, so and s is 0. And now I can write my trial form as a0 e to the 2t. Take the first derivative, take the second derivative, plug them inside the original one, make it equal to 3 to the 2t, and you can find a0 is negative 1 over 2. Okay, you already find the first particular solution. And second particular solution here is coming from the 2 sine t. So let's do the 2 sine t. So it is about the last part. So it is with sine or cosine. I need to check my solution in that form. T to the s, polynomial e to the alpha if there is an exponential cosine beta, nth order polynomial exponential sine beta. So I'm going to be looking for that trial solution. That's why I need to find what is s, and s was alpha plus e beta. How many times it's coming? Alpha is, what is that? There is no exponential. Alpha is 0. And beta is the coefficient inside the sign, 1. So how many times alpha plus e beta? Which means that how many times I is coming as a root. Since there is no I is coming as a root in the first step, then s is 0. And beta is 1 because it was the coefficient of sine. N is 0 because the coefficient of sine outside is only a number. Alpha, there is no exponential. That's why it is 0. And now I can check my trial form since there is only a constant. A, sine of t, b, cosine of t. Take the derivatives, plug inside the equation, make it equal to 2 sine t. We need to plug in here, make it equal to 2 sine t. Find a and b. Since there is only a sine, then this coefficient should be 2 and this coefficient should be 0. That's why I need to make this one equal to 2, this one equal to 0. And from two equations, two unknowns, you can easily solve them and find a and b. Plug them inside the second particular solution, and as a general solution, write your complementary plus the particular solutions you found. This was my complementary solution from the step 1, and this was my particular solution for step 2, and in this one is the particular solution for step 3. And the whole solution is going to be the general solution for your differential equation. If the initial value is given, you need to apply in here and you need to find C1 and C2. Okay? This is how we can solve the method of undetermined coefficient.